Great. Thank you very much, Amanda, and it's a pleasure and honor to be here. I'm going to frame my intervention using a few slides from the engineering context of AI, and then open up for discussions later on about what it means to have an ethical deployment of AI models. My area and background is in mechanical engineering with a focus on engineering design and the applications of AI in this space. And when we look at the use of AI systems in the workforce, there are many quotes from heads of organizations where um, the norm of the future is that humans will be working hand in hand with AI systems. So from the context of engineering, what does that mean? And how do we embed human principles and ethics into these AI systems that will be working hand in hand with humans? This is an example of a pretty standard software tool that's used by engineers across the world. And it's how products ranging from aircraft to chairs to automobiles are conceived on and realized. And so this is a human kind of using this tool to get an idea from their head or from a user requirements to a virtual representation that has the dimensionings and other components. And so you can imagine as this human designer is using this tool, they're implicitly bringing with them the responsible and ethical aspects. Would they be proud of such a design? Could they see their family safely traveling in the system that they're designing? And so the question is, well, what happens now when this human has to work hand in hand with an AI model that doesn't have these kind of human characteristics? And these are already going on right now, where we have these AI generated systems that are able to very rapidly learn and train on the geometries of different designs that were otherwise used for in the human dimension. And what that has enabled is a rapid development of AI generated products and systems that have similar characteristics as the human aircraft uh, system that I was showing earlier. And so this is end-to-end a AI generated equivalent that can explore and morph the space in a way that is very rapid and efficient. But it's not only the realization of a conceptual model on a computer. We have other machines that are now able to move from the instructions of a virtual model to actually physically manufacturing these products or components using additive manufacturing. And even in this space, there's a lot of work going on in how do you deploy AI systems to ensure the optimal and efficient way that these components are manufactured in the real world. Now, in many industries, including the aviation industry, it's really an assembly of components. So this is an example of a large-scale aviation assembly line where you have these components that were once in this virtual computer model that have now been manufactured in the physical sense and then are now being put together for the final product. And in many cases, when these products are being put together, there's an extensive engineering performance simulation to make sure that what is designed is safe, meets the high regulatory requirements of safe and effective, and uh, minimizes risk to people. So this is another simulation platform that not only designs a system, but also evaluates the potential performance of the product way before it's actually manufactured. So before any of us fly in an aircraft, extensive simulations are done at the particle level. So when this engine is deployed, how does the fuel mix with the air to create this combustion, and is this safe? In the same way that we saw the 3D models, there's a lot of work of AI being able to simulate at the particle level what these interactions look like. So on the left here, we actually have an AI generative model that is simulating if you poured water in a container, how would each of these particles interact with one another, and do they uh, um, satisfy the laws of physics? And on the right, there is kind of like the mechanics of how this is represented as a graph. And finally, I'll end with just a summary of it's not just designing or evaluating AI systems um, in simulation, but AI models are actually being used to control products and systems, from autonomous vehicles to simulating how an AI model would control a new drone design. And the rapid acceleration of these models is has created a very active field of simulation to reality, where you simulate an AI model controller in a virtual environment and deploy this on a real world system. And so I'll conclude by really just summarizing the current state of AI models in real world industries like engineering, and the question of ethical governance and these models being responsible really asks the fundamental question of how would uh, governments and policymakers even evaluate whether or not the use of these models are ethical and safe in engineering and other types of uh, industries. And where does accountability lie, especially in this hybrid model where you have the human in the loop, but also the human is working with these AI models. So I thank you for this opportunity and look forward to further engagements and fruitful discussions. Thank you.